Today we started our scale and similarity concept unit. So we're starting off very basic, not very much math involved today, just looking at some pictures and different shapes to learn about the concepts of scaling and similarity. So the first thing that we're going to do is we have a picture here of a student, okay? And it says we're going to use portraits A through E, to see how each one is the same as or different from the original portrait of our student. So we're going to go through each one individually and compare it to our original photo here. So if we look at A, it looks like I kind of took both sides of my picture here and kind of squished them together. He stretched taller and got a lot skinnier. Okay, so for A, it got stretched and a little skinnier. Okay, and we can see that even though I know it's the same person in both pictures, okay, he does not look exactly like he did in this top portrait. So we're going to say that he does not look the same as the original. Okay, and then if we look at B, okay, B compared to our original, okay, it's almost like I took that top edge of my photo and I squished it down, okay, pressed it down so it got a lot shorter, and it also got kind of a little fatter or a little wider, okay. And again, I can tell it's the same person, but if you look at his face, he definitely does not look the same as he did in the original photo. So B, we're going to say he got shorter and a little wider. And again, we're going to say he does not look the same. Whoops. Okay. C, little guy right here, C, compared to our original photo, okay, he looks identical to the original photo, but it's just a lot smaller. Okay, so C is a lot smaller than the original. But we're going to say this one does look like the original. Okay, and then we have D. Also, if we look at D compared to our original photo, he looks exactly the same. Okay, and it may be a little smaller or a little bigger, but they have the same, he looks exactly the same, even though the size might just be a little bit different. Okay, so we're going to say maybe just a little smaller, not by much, and we're going to say that he does look the same as the original. Okay, and then there's E. Okay, E definitely does not look like my original. He is kind of slanted off to the side there. It's like I took the corner of that picture and I kind of pushed him over. He is slanted. And again, even though I can tell it's the same person, in both photos, if we're looking at him in the first photo, he does not match the second photo very well. Okay, So number 2 says some portraits of A through E are what we call scaled copies of the original portrait. Which ones do you think are scaled copies, and explain your reasoning? So we haven't talked about this idea of something being scaled yet, but based off of the information that we talked about when we were comparing pictures A through E, um, we said A does not look the same, B does not look the same, C looks like the original, D does not, D looks like the original, and E does not look like the same. So if I'm talking about, I want to know which ones are scaled versions of the original, that is going to be C and D, okay, because they are the most like the original photo. Okay, they look the same, but they just have different sizes. Okay. So taking it a step further, if we ditch the pictures altogether, and we're just talking about this idea of what do we think it means to be a scaled copy, we want something that looks like the original version. Okay. It can have a different size though. It can be bigger or smaller. And then we do not want it to be stretched or kind of distorted. So if we look at our pictures A, B, and E, the ones we said did not match, okay, A, we said he looked like he was stretched and he was skinnier. B, he kind of got shorter and fatter. And then E, he's like leaning off to one side. So those were all kind of stretched or distorted versions of the original. C and D, he looks the same. He just has a different size. One is smaller. Okay. So now let's look, instead of pictures, let's look at the letter F here. Okay, we're going to identify all of the drawings that are scaled copies of the original letter F and explain how we know. So here's our original letter F, and then we have 7 more drawings. Okay, right off the bat, you should be able to eliminate drawing 4 here, because remember, a moment ago, we said for it to be a scaled copy, it must look like the original, not stretched or distorted in any way. And F definitely does not, or drawing 4 of F definitely does not look like our original version of F. Another one that I think we can go ahead and get rid of right off the bat is drawing 3 here, okay, because he looks like he's just been stretched out long ways. If we look at our original, he is 4 units tall by 2 units across the top and 1 unit in the middle. If we look at drawing 3 here, he's also 4 units tall here, but then it's like they just took this top piece out and the middle piece out and stretched them out way far. So that is not going to be a scaled copy. And then also what I notice here in my original, the top part is longer than the middle part. So if you look at drawing 6 here, the top part and the middle part are the same exact length. So that's not going to be a scaled copy. So we're down to 1, 2, 5, and 7. So let's take a look at drawing 1 here. Okay, this letter F is 6 units tall, 3 units at the top, and 1.5 units in the middle. Okay, a lot of students think that this one is not a scaled copy, but if we multiply 1.5 times 4, that's going to give us 6. If I multiply 1.5 times 2, that's going to give us 3. And if I multiply 1.5 times 1, that gives us 1.5. So you can see I took my original number, 4, and multiplied by 1.5. My original number 2 multiplied by 1.5, and my original number 1 multiplied by 1.5, and I got 6, 3, and 1.5, which are the new measurements of this letter F. So drawing 1 is in fact a scaled copy because I took my original measurements and I multiplied them by 1.5. Each one of them I multiplied them by 1.5. That is the key. They all changed by the same amount. Okay? So if we look at drawing 2, this one is 8 units tall, 4 units at the top, and 2 units in the middle. So if I look at my original drawing, originally it was 4 units tall, now it's 8 units tall. It was 2 across the top, now it's 4. It was 1 in the middle, now it's 2. Most students spotted that one pretty easy. That is twice or double the size. 4 times 2 is 8. 2 times 2 is 4. 1 times 2 is 2. So drawing 2 is in fact a scale copy. Okay, drawing 5 is 6 units tall, 3 units across the top, but it's 2 units in the middle. Well, if we look back at drawing 1, it was 6 units tall and 3 units at the top, but to use our scale, 1.5 was the middle number. Now they're saying it's 2. So I know if I multiply 4 times 1.5, that is 6. 2 times 1.5, that's 3. But that is not going to hold true for that middle value there. So 5 is not going to be a scaled copy. And then drawing 7 is 12 units tall, 6 across the top, and 3 in the middle. So I can do 4 times 3 gives me 12. 2 times 3 gives me 6. 1 times 3 gives me 3. So drawing 7 is a scale copy because I was able to multiply all sides by 3. So our scaled copies are drawing 1, 2, and 7. Okay, for drawing 1, it's 1.5 times larger than the original because I multiplied all sides by 1.5. Drawing 2 is 2 times larger than the original because I multiplied all sides by 2. Drawing 7, we said, is 3 times larger than the original because we multiplied all sides by 3. So in order for something to be scaled, it has to change on every side by the same amount. Here, it worked for 2 numbers, but it did not work for that third one, so it was not a scaled copy. So our last one here says on the grid, draw 2 different scaled copies of the original letter. So we've already done 1.5, 2, and 3. So let's do 4 times larger. Okay, and it's the same letter F. This is 4, 2, and 1. So if I want it to be 4 times larger, if it was originally 4 units tall, this time it's going to be 16 units tall. Okay, and it was originally 2 units at the top, so 2 times 4 is going to be 8. And then on the middle was 1 times 4 is going to be 4. So I just took all of my original numbers and multiplied them by 4. If I wanted to do one dividing by 2, that's going to get smaller. 4 divided by 2 is 2. 2 divided by 2 is 1. And then 1 divided by 2 is 1/2. So it's not going to fully touch that grid line there, 0.5.